another video, DraftScience, to the Puro this time. So style it Gary's Physics Implosion. Okay, now, just for context, right, I just listened to an hour of his Sunday show, and he's still defending this idea that consciousness isn't a function of neurology. No, it's some other kind of thing. It's living things have consciousness. Parameciums are conscious. They want, and they get hungry and thirsty, and they feel like going this way or feel like going that way. Don't have one single neuron, but they're somehow doing something we can't do when we're unconscious. But somehow they're conscious. And he's calling me insane. He's calling me having some sort of logical implosion. Right. I'm just saying, irony much? Yeah. It's preposterous irony. So again, just more validation, right? I must be doing something right if complete lunatics are demonstrating how much they're lunatics. I guess that doesn't necessarily prove I'm right, but well, it sort of does. Anyway, so let's play some of this crap, and I will do the counter-arguing and such. Same old routine, basically. So they do have a new list of interesting this and that's.
So, yeah, we're going to have that hangout in a bit.
Right, so, yeah, so we spent an hour so far talking about basically some kind of choice will thing. Okay, we're not programmed by our life experience. We're not programmed by genetics. Our behavior isn't basically a reflexive reaction to the world we fall into. No, we choose. We actually make real choice. We do things. We. The we that came from where? Was made by what? Does what? Making an argument that you can't create this Turing machine. It's using the word Turing machine instead of Turing test, right? There was the Turing test, which was you just fool something into thinking you're human just because it behaves human enough to fool you. And that's what we are. We're behavior. Obviously, we're behavior created by a mechanism that creates feelings and desires and in those kinds of impulses. There's a theater in our brain. Now, you don't have to create the theater to create the overt mimicking. You could have something mimic what we do. I can mimic other organisms that aren't conscious. I can mimic other conscious organisms that are having very different experiences than me. Mimicking something is not the same as being something. But clearly it does have an equal sign. The copy is just as good if all you're trying to do is create something that does the behavior. Obviously, nature created a system that's that creates the behavior in this very nuanced way, where we basically have one part of our brain being tortured and the other part comes to the rescue with a solution. It's just a silly, it's basically you are two things. You're the victim and you're the hero that's going to save the victim. The victim's being tortured by and tormented by the physical impulses, the visceral reactions, and the intellect tries to come to the rescue and give it comforting ideas and thoughts. And for this guy, a comforting thought is parameciums are feeling because they're alive. And then he went through some whole thing where he was talking about being dead, how somehow it's amazing that we recognize things when they're dead. We can't even recognize when things are dead. That's why we have to put them in hospitals and pump fluids into them and freeze them or do all kinds of crazy shit because they might still be alive. They look fucking dead, but they may not be dead. Duh. You haven't heard of that? You know, so he's all like proud of how good we are at recognizing when something's dead. We're not very good at it. We've buried some living people. We can't even tell when people are dead, let alone necessarily tell when organisms are dead. Never heard of playing possum? Anyway. This is just so frickin' pathetic.
I went and talked to Gary, got kicked out. Probably not welcome.
Yeah, well, look, that's right. You're not welcome. I mean, there's no point, all right? You kicked me out of your room, so yeah, I thought it was just a perfectly natural courtesy to just kick you the fuck out because you want to set the agenda in my room. Well, fuck that. I don't want to talk about your silly subjects, all right? The subject that's important to me right now is that I've sort of discovered the holy grail of physics, And yeah, I'm a little distracted by that subject. I really don't want to talk about some kind of bibble babble about feeling parameciums. I think that's a colossal waste of my neurology.
Back there anymore. Because all Gary wants to talk about is his scientific quote unquote theory. But he won't even admit it's a theory or a candidate. It's like the only option.
I don't know where I didn't admit that. I don't know where I didn't admit it's not a theory or a candidate. What I'm saying is it's one hell of a motherfucking candidate. Okay, and I'll go through the list of all the things it covers, all the dilemmas of science that it just completely ties all together with this beautiful little thread. Yeah, this, you know, and yeah, so I'll go through this list.
And I know because I figured out that it's true. It's like he's
Yeah, whatever. That's not what I'm saying. I obviously discovered it. Yeah, it's right in front of my face, and why wouldn't I say, holy shit? I mean, the unification theory's only existed for 100 years. Einstein spent his life seeking it. It's the most famous thing pursued there is. It's the tallest mountain you can climb in physics. It's about the most spectacular feat you can perform as a physicist. There's a unification theory that actually works. So why the fuck wouldn't I be a little distracted by the fact that I think I've got it, fucker? Gee, yeah, it's totally insane for me to have that reaction. And again, I'll go back to the evolution argument. Darwin's grandfather believed in evolution, right? He didn't even read Darwin's book, and he believed in it. All right, so he didn't even need Darwin's evidence. He already saw enough evidence in the world. And then Darwin went into the world and he discovered more evidence and said, holy shit, this evidence is overwhelming. Here's a book full of the evidence. But guess what wasn't in the book? The whole genome, chromosomes, DNA, alleles. None of that shit was in the book. And Darwin was already convinced. Most of the people who read it who were rational were convinced. There was enough fucking evidence. You only have to throw so many pigeons with funny feathers on their head in front of people and they figure it out. Yeah, it's evolution, damn it. Okay, we are doing it. We're selecting, we're creating evolution, we're doing it. Instead of natural selection, it's human selection. We made cabbages, we made broccoli, we made lots of shit. Yeah, through evolution, through simulated mock evolution. Duh, it's a fact. And they didn't even need genomes. I'm just saying that this fits. I think I'm at the Darwin stage, not the grandfather stage. And yeah, it works. It's going to win. It's the winner. It's the right theory, buddy. So haha on you. You're going to have stupid lunatic, okay, on you, buddy.
taken and, done a little sketch. Here, sketchy sketch. Obviously, it's going to be...
Well, yeah, right. Physicists never do sketches. No physicist has ever done that. Sketched a model of something. Feynman diagrams. Duh, buddy. You're a hero. Didn't do sketches. Didn't do sketches on blackboards all the time. No, that never happened.
Right, well, what about all the missing parts? Well, it's going to work out.
Missing parts. What? Again, point them out. Show me the missing part and I'll show you the answer. Give me the problem you want me to solve and I'll solve it. Alright? But this is just bullshit. Well, I can only do... There's certain limitations to that stipulation. But certainly it's there. It's doable. And I think if you do the right experiments, it's demonstratable.
Oh, you obviously could see that.
Oh yeah, right. And Einstein didn't do this metaphor of bent space. No, we never use metaphors. We never use diagrams or visualization aids to understand a mechanism. No, that never happens in physics. That's outrageous. How dare you? So don't dare use a school of fish as a metaphor because that's not Einsteinian enough. Einstein would never go near fish. Fish are smelly. That's not a proper metaphor. Fuck you.
It's to this next level of ridiculousness. I mean, I appreciate...
Yeah, no, what's ridiculous is to deny the existence of neurons. To deny that they have a specialized function, which is synthesizing the illusion of existence. And that's all it is, an illusion in your fucking head. Alright? It's not in a paramecium's jelly It's not in a paramecium's flagellum. It's not in a paramecium's carbon molecules. It's just an idiotic, preposterously nonsensical theory to talk about how the parameciums are sensing their environment with a sense of feelings. Yeah, feeling their environment, not sensing it.
The confidence to have an opinion, stand behind it. But to sketch out a physical theory and then be surprised, honestly, to be surprised that people would need some sort of demonstration besides the fact that it's the evolution of this.
Yeah, besides the fact that it fits all the evidence. Oh yeah, besides the fact that it's consistent with the evidence. Yeah, that's a silly idea, right? When something's consistent with evidence, it's silly to think it's a good idea, that it matches. Yeah, consistency with the evidence. Yeah, that's totally a stupid thing to do. Don't be fooled by consistency with evidence.
Logical system, it has to be true. It just has to be.
Well, that's not the argument I've made. I'm just saying it's the damn best theory around. It doesn't rely on magic, and it doesn't rely on invisible, and it doesn't rely on made up shit. It relies on what should be intuitive to almost everybody, in a sense that it gets simpler as it gets smaller, and the basic dynamic is going to just end up being simple kinetic exchanges of directional information, and that's all there is. It's, yeah, makes sense. The universe is dumb and simple, not complicated and fancy.
I mean, and to feel that way is one thing, but then to be like...
I don't feel a particular way. I think a particular way. But again, you can't make distinctions between these concepts. There's things you have that are called thoughts that are logically connected. And then there's things where you're, want some apple pie.
Actually expecting other people to buy that way, that's just...
No, I'm not expecting it, actually. And it's exactly, and you're just proving my point, that the reason why physics went on a sidetrack for 100 years is because you're all small-minded bigots, okay, that you really don't give a shit about the truth or the facts. You want a fancier story. You want the three bears to have, silver hair and to have, magic paw powers, and, it's just not good enough, just the standard fable. You want some kind of human glorifying fable of mystical and magical particles that somehow give you free will or something.
I'm saying, right? Of course people are not going to be convinced that you would have to have a system that I can compare with the current system.
Yeah, okay, so let's do this comparison. Alright, so this system, okay, first thing, the first obvious thing, all the forces that we call forces, gravity, electromagnetic force, magnetic force, even nuclear forces, they're transmitted, not instantaneously. The fastest thing transmitted in the universe is light. There's no other force that we've found that moves faster than light. So this idea that something called a photon, something like a photon, would be this mechanism of being able to create a force that moves the speed of light. A force that moves the speed of light being made of light sort of kind of makes sense. So that's one problem solved. We also know that electrons are selective in their interaction. They don't interact with certain photons of a certain frequency. So the real thing that matters is how far apart the photons are. And then one's a radio wave and the other's a cosmic ray. And what's at the other end there we couldn't tell anyway, right? Because we'd have no way to detect them. We can't even barely block cosmic rays. We can dig holes way into the ground and fill them with water and do all kinds of things to try to block cosmic rays, and you still can't block them. They'll go through everything and anything. And so to imagine there might be something a little bit smaller than that, even smaller, that could go through even more stuff called gravity that's moving the speed of light, doesn't seem too far-fetched to me. That sounds kind of, well, that sort of makes sense that, yeah, the end of the scale is just an arbitrary end where we've identified particles that we can identify, but there still could be ones we can't identify. Alright, consistency with, and this selectivity of our electrons has to be understood, because that's what quantum mechanics is. Quantum mechanics is about the reaction of electrons and photons. Not photons and photons, not blah 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 blah. No, it's the reaction of these collections of photons. Well, I won't get into the mechanism, but I'll just get into these things. I already made those arguments in the previous videos. Consistency with the inverse square rule. So here you have these forces: gravity, magnetism, and the electrical force. All these forces are proportional to this idea that it gets stronger as you half the distance away. So if I move twice as close, the force gets 4 times stronger. And likewise in retraction. So if I double the distance away, it's 1/4 of the size, just as my hand is 1/4. It's the same effect as the illusion of distance with light. So again, wow, that sort of fits everything. It sort of fits that the magnetic and electric forces probably have to have something to do with something moving in a straight line path to create the inverse circumstance. The inverse circumstance is created by particulates being shadowed by a mass from their straight line path. Alright, movement in a straight line perpendicular to field lines. So there's another, just here it just says it loud and clear, okay, that field lines are created around something, and those field lines will create movement in a perpendicular to the field line. Not at an angle, not at anything else. No, always perpendicular. And why is that? Well, that's because it's getting hit from both sides equally, and the thing has to go off in a straight line. But that's because the things hitting it are moving at a straight line. They're consistent. They're angular. They're straight line projectiles that have a consistency, and that's what's creating the field lines, is the consistency of those photonic paths going from point A to point B in a straight line at the speed of light. That's the only way you could create a straight line trajectory off of field lines. So it explains that. Alright, magnetism as magnification through polarization. So this particle theory, all you do is add polarization to it, and that way you can flavor it, strong or weak, in the sense that you can be more permeable to photons polarized in one direction and less permeable to ones polarized in the opposite direction, just like a filter. And if you send out photons, if photons come through you and you send them all out in one direction, and that direction happens to be the direction that the thing opposing you is susceptible to, then you will magnify the effect of gravity on that object. You will magnify the force, the amount of particles that can affect it, the distribution of the impact, just by changing polarization. Nothing fancy. Just by changing polarization, you will magnify, enlarge, and make bigger the effect of the interaction. That's, again, the function of electrons. They do it all day long. Alright, electric field has 1/4 phase polarization. So now you can explain magnetism is this polarization, and the electric field is this polarization. So you can only go from here to here because it's all the same, right? The verticals extend all the way through. So all you really have is this 90 degrees to work with. And so one set of polarization is at this 90 degrees, and the next polarization is at this 45 degree angle and the 45 degree angle. So it's a different set of 90 degree angles that overlap. And that's why the electric field induces a magnetic field, and that's why the magnetic field induces an electric field. It's because the fields are very similar. It's just a change in the phase of the polarization. So again, another phenomenon. Not only does it explain both magnetism and the electric field in their basic function, but it also explains the connection between the magnetic field and the electrical field. Alright, big one. Time dilation, based on retardation of atomic metabolism. I mean, here, out of nowhere, not even looking for it, not even searching for it, it just falls out of the when you start doing the math, the school of fish math, when you start thinking about the metaphor of a school of fish and the fact that the fish are moving the same speed. They can't change their speed, so they're all moving 30 miles an hour, let's say, and they're all swimming around in a ball. It's exactly the same amount of energy as all the fish swimming in one direction. And that if you start to change the fish and say, okay, that school of fish is now going to move in a direction, you'd have to concede that there wouldn't be as many fish doing the pattern anymore. So whatever pattern they would do would have to change if all of a sudden the fish are spending more time moving in a direction. So here we have time dilation explained as merely the consequence of distracting the energy of the system from its pattern to movement. Again, big one explained. Big, huge one explained. A connection, not only does this unify all the fields, it also explains time dilation. I mean, come on. Fuck. It's rather amazing. Alright, and then the last comment would just be kinetic reality. This idea that it seems a phenomenon that which we should take notice of. That the most extreme kinetic interaction you can have, direct contact between two things, head-on collision, has no impact on the universe whatsoever. Head-on collisions mean nothing. Something leaves going the speed of light in that direction, something goes that direction in the speed of light, none of them exchange mass, nothing's exchanged, no directional change. You end up with exactly the same universe if they hit each other or if they don't hit each other. This is a phenomenon worthy of taking note, and this kinetic theory, okay, now explains why there's no friction in the universe and why there's no opposition to velocity in a direction in the universe. So anyway, so I'm just work on these couple of other little statements. The work of forcing change against polarity. So work, what we call energy and all that kind of shit, has to be expended to force things against their polarity, to force the electrons to bunch up in a group because they don't like each other. Electrons don't, things of the same polarity don't like each other because they're producing gravitons, okay, that are exactly the kind the other stuff doesn't like. There are dense ones that are ones that hit, not ones that go through. And so that's why like things don't like each other, is because they're producing the exact radiation that makes each other sick, so to speak. And so they are pushed from each other. And if you overcome that tendency to be pushed away, if you force them together, you have to do work to do that. You have to release other photons, regular photons of energy, and push them, okay, into that association they would prefer to avoid. That's a big one. And then movement versus vibration is really another way of saying the same subject. Is that movement of schools of fish. The fish themselves are all moving the speed of light. They can't move some other relativistic speed. There's only the one speed, so you can't run away from the speed of light. You can't move faster than the speed of light. So if some light's chasing you, you can't escape it by running faster than it as a fish. Alright, so that's probably, so I think this is a pretty good reason. This is like noticing that, being, say 300 years ago, Darwin's grandfather noticing that, there's this similarity between us and the great apes. And it seems very curious that there's mammals swimming in the ocean. And, just to start to look at other organisms and see how they've changed over time. So you dig up a few fossils and you just notice this change taking place. And then even in your lifetime you see people breeding animals, and what are they doing? They're just selecting the pairs, and they're advancing the attributes they're selecting for. And that would be perfectly sensible to say, if the animals are left on their own, that the environment is going to select which animals survive. That doesn't take much of a leap. That's less of a diagram of evolution than this is a diagram of physics. And I'm saying that diagram 300 years ago was perfectly reasonable. And the only reason why people wouldn't say, yes, it seems obvious, is because they have Jeebus in their brain. They can't see straight. But that's the only reason. Is because they have a pre-existing bias. And what exists is that these people, these physics people have a pre-existing bias. They want duality. They want quantum mystery because it sells books and makes them all seem like they're really fucking smart. And all they're doing is talking shit.
And going, but it's all made up of made-up entities. Well, you're calling things photons and gravitons that aren't photons or gravitons. But these
well, again, it's not very complicated. I have to use some sort of common, language we all understand. Photon generically would, in my opinion, be understood as the stuff moving the speed of light. That's what photons do. They move the speed of light, whether they're a cosmic ray or whether they're a radio wave. That's what they do. The photons move the speed of light, and the gravitons are essentially within that electromagnetic spectrum, but they're just in it in the sense that they're not associated with a frequency and therefore can't be detected by an electron. You can't see the effect of a photon because it will not produce energy. It will not produce any noticeable effect beyond the fact that you see it every day with gravity. You see the effect of gravity, but you can't measure gravity in terms of seeing the change in us. At least we can't do it yet.
Kind of quanta, some new concept of yours, no more visible than any of their stuff. Gary wants to say that magnetism is invisible. I'm like, well, you can pretty much see that.
I didn't say, I had nothing to say about magnetism. You were making the argument, okay, about what something is. It's obviously invisible. I'm making the argument that you're claiming there's a magical force that pulls things together or repels things. That it's not a physical thing that's pushing these things, that there's not some agent doing the work. You're saying the agent is some mystery mechanism within empty space itself. So you're saying the nothing is controlling the something. I'm saying something is controlling something. That something's influence something. That something does something to something. I'm saying it's a cause and effect universe, that it's always been cause and effect. It's always been the same energy forever, so to speak. And it's just that energy reshaping itself through interaction, period. It's a school of fish. They're just swimming in patterns. Sometimes the fish, like clouds, could look like an elephant. Or sometimes the school of fish could look like a bagel. Sometimes the school of fish can look like all kinds of things. But it's the same fish doing the same moving.
There's a magnetic force. See, yeah, but how by magic in the field? It doesn't matter. Yeah, we don't know what the field is yet.
Yeah, we don't know. Well, the point is, I'm saying we do know. So it's no mystery, okay? You could say, well, why are animals different? And somebody could say evolution. They could say, well, we don't know. And the guy could say, well, it's evolution. And they could keep saying, we don't know. No, you don't want to know. The truth is there to grab. It's sitting right there. You can pick it up and you can hold it in your hand and say, oh shit, it's photons. Yeah, I got it. The truth. I don't have to be living bullshit anymore. I don't have to sit there and sit around going, wave particle duality. Waves go through things and then particles ride on top and then they decide and then they read our minds and then they, all that sounds like a pile of crap.
We're looking into that.
We are. Who? Where are they doing that? Feynman looked at it and he took a shit on it. He wiped his ass with it. Okay? He didn't give it any real... He didn't apply any nuclear physics to the problem. It seems like none of these physicists seem to understand that matter isn't matter. Matter is electrons and protons and neutrons. Okay? Matter isn't made out of bricks. It's not made out of solid stuff and stuff bounces off of it. That's not how it fucking works. Except on the fish level, but not on the atomic level. Electrons are full of stuff going on inside of them.
But the fact is that quantum mechanics was invented to model the atom, how the electron...
Yeah. See, he just say how the electron... He's going to say that, right? But why is everybody talking about photons then? If it's about how electrons react to photons, then we don't have an argument. That's not what people are talking. People are talking like the photon's doing something. The photon's carrying something. It's carrying nothing except its polarization. It has no other suitcase.
Electron is captured, and it ends up having a lot of implications because basically that's what drives, all of chemistry is how the...
Yeah, well, duh. I don't see why I need this bullshit. Like I don't know that. That's my argument, jackass. So another thing to understand is, I think I drew a little crappy picture of it because I just was playing with it a little. So this is basically quantum mechanics the Feynman way, okay? So you can think of a clock spinning, and with time, it's going to have a different element of probability of what position it's going to be in. It's going to have an impact on how these elements would add up as terms of directional information. So as Feynman would do this argument, you would spin this clock, and for each spin of the clock, for every position, there would be a different kind of reaction. And it's basically, if you did this spinning of the clock, if you just did it round and you just took the segment you did with each passing of time, you just took that segment, that piece, and tied it onto the end, just like Feynman does with the vector arrows, but just take the segments and just add the segments up, you'll just make a circle, right? The clock goes around, you just duplicate the circle. But all you have to do is switch, just invert it with every quarter turn, and you end up with a perfect sine wave. So this is what you end up with if all you do is just invert it every quarter turn. So just invert the clock every quarter turn, and you end up with a sine wave. And that's the probability being realized in a waveform, in the sense that this would be the 16% probability, this would be the 4% probability, this would be the 0% probability. And then you'd go right back up again to 4 and 16, and then 4 and then 0, and then 4 and then 16. And that's all it is the pattern repeating itself. Duh. And that's what's happening in the Newton refraction in glass, and that's what's happening in the two-slit experiment, fundamentally.
Electron is behaving in the molecules and atoms that they're part of, and you can't just say, oh, well, I have this intuition, it'll be this way, and it'll all work out.
It's not an intuition, again, it's the facts, okay? I mean, the fact that atoms are in motion, and the fact that electrons are in motion, and that the electrons might even be vibrating in not only are the electrons themselves wobbling, their orbit is wobbling around the atom, and then the atom itself, the nucleus, is wobbling. So you have all of this movement, this wave generation capacity in the atom. You don't have any intrinsic wave generation capacity in the photon, none whatsoever, and yet physicists are looking at the photon saying, look at the wave they're creating. They're obviously not creating the wave.
No, people had similar intuitions. It didn't work out. It was complicated to get a mathematical.
Yeah, well, again, it's not. The point is that it wasn't complicated. A guy did it 200 years ago, all right? And just because he didn't have a few nuances of explanation. He couldn't explain because he didn't know what friction was in terms of a non-friction environment of the atom. They didn't quite visualize atoms as a. They didn't have a model. This is before Bohr. It's before the atomic model. So they'd had no explanation for certain things like why this gravity wouldn't be an impediment to movement, and why it wouldn't create friction, or why it wouldn't create heat. But now we can understand that, because now we can model it as a school of fish, and we can explain that it doesn't matter. The fish are doing the same. They're doing the same exact amount of energy is being consumed by the fish when they're swimming around in circles as when they're swimming in a direction. And it just looks like more when they're swimming in a direction. But it's exactly the same amount of movement.
System that works. Not that simple. And quantum mechanics solved that. And
well, again, you say it solved something. I don't think it solved anything. It's just a simple pattern repetition, and that's all it is, really. And for each circumstance, you have to write a new formula. So again, that's another failure of quantum mechanics. What is quantum mechanics? You can't write quantum mechanics on a piece of paper for me to sit there and analyze it in every circumstance. Because for every circumstance, you're going to change the formula. So don't tell me about how quantum mechanics resolves something.
as far as, well, what's behind the math? What's it mean that we have this quantum field that we calculate over?
Yeah, it's not a quantum field. It's a pattern of vibration in molecular structure. Atoms have moving parts. They react differently when they're in different phases of their movement. Okay, you're a different person when you're standing up than when you're sitting down. If you were playing baseball sitting down in a chair, you wouldn't hit so many home runs. Okay, so yeah, atoms are like that. Sometimes they're sitting down and they behave a certain way, and then sometimes they're standing up and they hit home runs. Not too complicated to figure that one out.
Well, mostly it just means that we still believe in space. We rely.
Well, whatever this means, we still believe in space. You believe in too much space. You believe space has power, and it tells things how how attracted they should be to each other, and it bends and does this as it interacts with something, as if the space was not just space. It's obviously some sort of medium that transmits information coincidentally at the speed of light. Even though the fabric theoretically should be able to transport information instantaneously, what does it do? It decides to, well, let's just send photons instead.
Separation between...
I mean, you know, Einstein's bent fabric bends at the speed of light. Doesn't that say something? Like, why is the bending of the fabric of space contingent on the speed of light? Why is the speed of light relevant to how fast the fabric that the light's traveling on, you know, bends? Why should those two things be the same? Oh, that's right, because the empty space is empty space, and the photons are doing all the work. The gravitons. They're communicating where the thing is going to go. They're causing it to go where it goes. Things are forced into their position. They do not go there because the space told them so. They go there because a big pile of fish come crashing into it and say, you're going to go this way for a while.
Features of a system, energy distributions, and the fact that there could be a distribution comes from the concept that there's space, which is the concept of distribution.
Yeah, whatever. Just what a pile of shit. And obviously, I've been saying 5 years ago that time is distance, and you know, I certainly know what, I think I have a better concept of what space is than you people who are just making it up. Like, things are instantaneously communicating through space, but we can't find out how they're doing it because it's a secret code they're sending underneath the space.
So, pretty successful in a pretty difficult situation. You can't just say,
well, whatever. Pretty successful again, says you. Pretty obvious. Like I said, Newton had already figured out there was a pattern. The fact that there's a pattern doesn't mean this is the grandest piece of formulatic insight ever. We figured out that when photons interact with electrons, electrons are changed in their direction, their trajectory changes, and the photon's trajectory changes. Wow, what an insight. No, not much of an insight.
my system's obvious.
I really don't need to call it quantum mechanics to call whatever you do to describe that circumstance. You call it something. It just is sensible to call it something. You don't call it dog do. Recognizing the fact that those patterns are systemic to the function of matter and the transmission of energy. I gotta turn my food off so it doesn't overfood. Yeah, overcook. I gotta put the potatoes in. Anyway, so I gotta speed this up, get this done so I can finish making my dinner.
It makes more sense. That is at the insanity level of...
Yeah, so again, he's calling, you know, pot calling the elephant black or something. I don't even know what, I mean, you're loopy enough not to acknowledge the existence of neurons and their specialized function, and yet you're going to call me insane? Yeah, no sale.
You know, and then he says it's a religion, like what I believe is just because it's a religion. When in reality it's a lot of experiments and numbers and things that all correlate and work out.
Well, again, correlate and work out how. You have no unification theory. Quantum doesn't work on big scale. It all falls apart. Einstein's relativity theory, if taken seriously and actually run as a thought experiment, doesn't make any sense because it basically says you can kill your father before you were born. So, sorry. And nobody can even do the general relativity math. so nobody can even check if somebody did it right, because nobody can do it right. It's so convoluted. This, on the other hand, is straightforward, and it comes down in the end to kinetic exchanges of directional information. Not complicated at all. There's just a hell of a lot of information. There's just a hell of a lot of these little buggers buzzing around. Not twice as many as you thought. You know, you think the universe is full of stuff, but no, it's full of a lot more stuff than you realize.
It's like when you double check, it's like, oh, I get the same answer kind of situation. Gary's just spouting it out of his head, and he thinks actually he can say to other people that they're the ones that are just being faith-based.
Yeah, that's right, because I'm saying I've done it. It unifies. It's evolution. It's right here. Here's the theory of evolution as a correlate to physics. What evolution did for an understanding of biology, this does for an understanding of the mechanics of physics. It's the answer. This is how it works. Yeah.
His knowledge that his system is correct is just his own judgment. He said it in the room last night.
I never said anything like that. What I said is you've given me no reason to doubt a single aspect of this. You've given me no reason, no evidence, no circumstance that is beyond explanation with this theory. This theory explains everything, and it doesn't do it in a way that is completely closes the door and basically says it's no way this could explain this phenomenon. There's a way and it can explain it so far. I haven't run into a stumbling block where I said, holy shit, I can't explain that.
Like, well, I've looked at it and nobody's more qualified than me.
Yeah, well, I'm just saying, where's the evidence of something else? Again, if I have no reason, why would I be anything else than convinced? If there's no reason to doubt, why would I doubt? For the sake of it? That seems kind of silly.
And you're not even measuring whether the mathematical predictions that your model doesn't make, you're like,
well, it doesn't make. Again, I've told you it does make predictions. It makes predictions that there is no relative velocity, okay? There's just absolute velocity, and so that should be detectable in some manner or other. I've made arguments that if you give me the experimental capacity to do the two-slit experiment with aimed photons, I will dispel the idea of any Heisenberg impossibility, and I will demonstrate that you can know exactly what slit the photon went through, exactly how it went through it, and you'll end up with the same pattern, so there won't be any field that you had to crush or any kind of knowledge that you had to have to destroy some kind of magical field that was floating around the photon. So yeah, I think I can disprove the existence of any of this nonsense that photons are reading our minds and telling whether we're watching them. Yeah, I can prove that to be absolute crack shit stupidity nonsense.
It does make them, they'll be right, obviously. Why would I make wrong predictions? It's sad.
Yeah, I just predict that you're going to be the one with sad on your face. Yeah.
So that's over. But anyway, we're going to have a hangout here, whomever wants to come.
Right, it's just the same. Holiday, and you know, that's what's scary, right? Is Holiday seems rational by comparison to Piro. So it makes Holiday think like he's actually on planet Earth, because he actually isn't falling for the, oh, we're all specially special in terms of our reaction. You know, instead of just conceding that, yes, we have this mechanism that creates sensation, and sensation is meaningful and it has a to it. Okay, it's not a nothing, it's a something. We can identify it as something different than anything else in the world. A feeling is different than anything else in the universe, and we can identify it as that. but we're not doing something. We will, we control, we don't we anything. We have a brain created by our life experience, programmed by it. The words we speak, programmed by culture. You speak English, you don't speak Chinese. You are totally limited by your personal exposure to the universe. And that has programmed you. You are not free to just jump out of that program and speak Chinese and, play the piano and, fly to the moon. You just can't do any of that shit except in your imagination. So anyway, enough of a video. So anyway, I'll try to remember to post this crap in the description just so you have it. And try to write them up a little better in future. So till next time.